Welcome to your lesson on elimination. So this is the second method on solving a 2x2 system of equations algebraically. And what we're going to do is we are going to eliminate one of the variables. That's why we call it elimination. So the idea is that we can add these two equations together and one of the variables will cancel. So for instance, right now, if I add these two together, negative 4x plus 4x is 0x, so that cancels. Negative 2y plus 8y is 6y equals. And negative 12 plus negative 24 is negative 36. So I successfully used elimination because when I added these two equations together, one of the variables eliminated. Now it's just a matter of solving for y. So I would just need to divide both sides by 6, and I get y equals negative 6. Now there's one of my answers. I just need to go and get the other answer. So I need to find my x value. I can use either of my two original equations. I'm going to use this top one because the numbers are smaller. And what I'm going to do is I'm going to replace the y with negative 6. And now I can solve this equation. So first I'm going to distribute the negative 2 to the negative 6. That gives me positive 12. Now I can move my 12 over to the other side, so minus 12 minus 12. I get negative 4x equals negative 24. And then I can divide both sides by negative 4. So we get x equals positive 6. So I'm going to write my final answer as an ordered pair. X first, 6, comma, negative 6. And that is my solution. So here's our second example. If I add these equations up right now, let's see what we get. I would get 15x. That's a plus 1y minus 7 would be negative 6y equals negative 9. None of my variables were eliminated. I still have an x and a y. So what I need to do is instead of just adding them up, I am going to multiply one or both of my equations by some number so that when I do add them up, one of my variables will cancel. So I have my options. I'm looking at my x's. I have a 5 and a 10. So if I wanted these to eliminate, they would need to be the same number but opposite signs. So if all I did was multiply this top equation by 2, I would get a 10x up here as well. And then I'd have both as 10x. And then I just need to make one of them a negative. I can also do the same thing with the y here. I have a positive 1y up here and negative 7y down here. So what I could do is multiply this top equation by 7. So I'd have a positive 7y on the top and a negative 7y on the bottom. I'm going to go with my first method. I'm going to get rid of x. So I'm going to put parentheses around this entire equation and I'm going to multiply it by negative 2. Now I want to be sure to multiply it by a negative 2 so that I get a negative 10x because the bottom equation had a positive 10x. So you always want the same number but opposite signs. So here's what I get when I multiply every single term by negative 2. I get negative 10x minus 2y equals negative 18. Now let me bring over that bottom equation, not changing anything to that one. And now let's add them up and see what happens. Negative 10x plus 10x cancels. Negative 2y and negative 7y makes negative 9y equals negative 18 plus another negative 18 is negative 36. Great, my x's canceled, so I know I did that part correctly, and I can finish solving by dividing both sides by negative 9, which gives me positive 4. So there's one of my answers. Let me come back to my original equation, replace my y with 4, and solve for x. I can use either equation. I'm going to use the top one because the numbers were smaller. And I'm going to replace the y with a 4. So I didn't need to use parentheses this time because there was nothing in front of the y. So there's nothing to distribute, and so the parentheses were not needed. Let me subtract 4 to the other side to get rid of it. I get 5x equals 5, And then finally, divide both sides by 5. I get x equals 1. Let me write my final answer. X comes first, and then y. So 1, 4 is my solution. Let's look at this problem. If I were to add these two equations up right now, would one of my variables cancel? Definitely not, because neither of my variables have the same number but opposite signs. So now I want to look at each of my variables and each of my equations and decide what's going to be easiest here. So I have a 2x and a negative 5x. Well, those aren't even multiples of each other, so that might not be the easiest thing. Then I have an 8y and a negative 20y. Those aren't multiples of each other either. So what I'm going to have to do this time is multiply both equations by their own numbers to get the same number but opposite signs on one of my variables. Let me show you. Let's say I want to get rid of the x's. I could multiply my top equation by 5 and multiply my bottom equation by 2. Let's see what happens when I do that. On the top, be sure I multiply everything. I get 10x plus 40y equals 30. On the bottom, when I multiply every single term by 2, I get negative 10x, negative 40y equals negative 30. So my goal was to get rid of the x's. So I took what was on the bottom, the 5, and I multiplied it on top. And I took what was on the top, the 2, and multiplied it on the bottom. And I made sure that one of my variables would come out as a positive and one would come out as a negative. So the top came out as a positive 10x, the bottom came out as a negative 10x. Now, when I add these together, I know that my x's are going to cancel because 10x and negative 10x cancels. Oh, something strange happens here. 40y and negative 40y, those cancel also. So what am I left with on the left-hand side? 0, nothing. And on the right-hand side, oh my, 30 and negative 30, those would cancel also. That also leaves me with 0. So I don't have any more variables. So I stopped doing this problem, just like in substitution. I stopped doing the problem. I look at what's left. 0 equals 0. I say, is that true or false? That is definitely true. 0 is equal to 0. So that means I have infinitely many solutions. Take a look at this one. I have negative 4x on top and a negative 15y on top. And on the bottom, also a negative 4x and a negative 15y. If I were to add those two equations right now, would either of my variables cancel? They won't cancel because right now they both have the same signs. They're both negatives, whether I'm looking at the x or the y. They're both negatives on each equation. So I need to fix that, and I need to multiply one of my equations by a negative, or let's make it a negative 1. So I'm going to multiply my bottom equation by negative 1. Didn't matter if I did the top or bottom. So it's going to change the sign of everything. So now it's positive 4x, positive 15y equals negative 10. And on the top I have negative 4x minus 15y equals negative 17. I didn't change that one. Okay, let me add up my equations now. Negative 4x and positive 4x cancels. Negative 15y, positive 15y cancels. I'm left with 0 on the left-hand side again. And on the right-hand side, if I add those, I will get negative 27. Again, I don't have any more variables, so I stop doing the problem. I look at what's left and decide if that's true or false. This is most definitely false, and that means I have no solution. So these two lines are actually parallel on our coordinate grid. Okay, now it's your turn. So look at this system of equations. I want you to solve it through elimination, but be careful. Some part in there might trick you. And then we'll talk about it tomorrow during class. See you then.